Hello everyone, welcome back to JD Science Prep. Today we will be discussing writing the formula for ionic compounds when given the name. We're going to go through a few rules and then we'll go through a few examples. So rule number 1, it states when writing the formula for ionic compounds, we're always going to write the cation first and then the anion. So the positively charged ion will be written first, and then the negatively charged ion will be written second. So rule number 2, make sure to balance the charges of the two types of ions using the swap and drop rule. So when we are going through our examples, we will discuss what that swap and drop rule means. So I'll just underline it right there. The swap and drop rule, we will come back to that. Rule number 3, if needed, break the name into its ions before you write the final chemical formula. So again, when we get to our examples, we will be breaking the name up into its ions and then combining those ions into its final chemical formula. And finally, if there are two subscripts in a row in a chemical formula, we are going to use brackets to separate. So that will mainly be when we have a polyatomic ion in our formula. We will be using brackets when we have two subscripts in a row. So let's get to some examples here. The first one we have is sodium chloride. So if you look on a common ion sheet, you will find that sodium will have a 1+ charge, and chloride will just have a 1- charge. So as you can see, this 1+ charge here and this 1- charge there, they will just cancel one another out. So we will not even talk about the swap and drop rule here. So Na plus and Cl negative, when they are finally bonded together, we can just write the formula as NaCl. Okay. All right, let's move on to our next one. Number 2, we have potassium nitrate. So we're going to get into working with polyatomic ions here a little bit. But again, let's split it up into the cation and the anion. So potassium, if you look on your common ion sheet, you'll find it is K+ or K1+. And nitrate, this is our first polyatomic ion that we're going to talk about, is NO3-. So polyatomic, that just means it's going to have more than one species that makes it up. So we have nitrogen as well as 3 oxygen. That's going to make up NO3-. I'll just erase my arrows really quick. So again, this group of ions that we have potassium 1+, and we also have NO3 1-. This 1+ and this 1-. Again, they're just going to cancel one another out. So we do not need to swap and drop at all. So this, written as its chemical formula, will just be KNO3. That's it. That's all. So if we look at example number 3, barium iodide, again, we are going to split up the ions that make up this compound. So the first one we have is barium. So that's going to be, if you look on your common ion sheet, Ba, and it's going to have that 2+ charge, while iodide will be I-. Okay, so if we isolate each ion, we can figure out the overall charge. So Ba2+ is going to have a 2+ charge, and I- has an overall 1- charge. So we can see that these two charges will not neutralize one another. if we take the overall charge from a 2 plus and a 1 negative, we will still have a overall charge of 1 plus. And since ionic compounds have to be neutral, we must figure out a way to make this compound neutral. So in order to neutralize this 2 plus charge here, we must have one more iodide ion, because if we have one more, we now have a 2 plus charge coming from barium. And then, I'll just erase this here really quick. And then if we have two iodide ions, we will have a overall charge. All of this, I'll circle all of that, will have a 2 negative charge. So this 2 negative charge will neutralize that 2 positive charge, and we will have ourselves a neutral compound. So this is the first way you can figure out how many anions we will need here to neutralize Ba2+. We'll need 2. So our overall chemical formula will be Ba, and we're only going to have one of them, so we will not need a subscript, I2, because we need one iodide here and another one in order to get this 2 negative charge to neutralize that 2 positive charge. Now, we're going to discuss the swap and drop rule here. So this is another way we could figure this chemical formula out for barium iodide. So Ba, again, will have that 2 plus charge. Iodide will have a -1 charge. Now what the swap and drop rule is, we can take the charge of Ba, so it's 2 plus, and we are going to swap and drop it right beside I negative. However, we are not going to include the charge of this. Okay, so all we're swapping and dropping is the digit. Okay, so that 2 is going to go there, and since -1, the number along with -1 is just 1, since we never write the subscript 1 beside a species, we do not need to write anything here. So if we follow the swap and drop rule, we will get Ba I2. So we get the exact same thing using the swap and drop rule as we would counting out our overall charges. So our swap and drop rule, if you can master it, it is a lot quicker while writing the chemical formula for names of ionic formulas, or ionic compounds, sorry. So I do recommend you get a good understanding of the swap and drop rule. Finally, we have one more. We have aluminum sulfate. So again, a little bit of a tricky one. We have Al, and that is 3 plus, and we have sulfate, which is SO4 2 negative. So we can see our charges. We have 3 plus and we have 2 negative. They do not cancel one another out. So this is another instance where we will use our swap and drop rule. So we can drop this 3 down next to the sulfate, and this 2 can be dropped down by aluminum. Now, this is where we're going to get into the use of brackets. So we can write down Al2, we got that from our 2 negative charge on SO4, and after that we have SO4 3. Okay, so we can see in this little bubble right here, we have a 4 and a 3, so 2 subscripts right beside one another. We cannot have that. Somehow we need to separate it. Okay, so let me just erase my little bubble here, and we can separate this with brackets. Okay, so we'll separate the 4 and the 3 with brackets, because now this 3 applies to the whole of SO4. So what this means, let me draw it out in a little bit of a different way. This means that we have 2 Al3 negatives, and we get that from this subscript here. Okay, so if we were to circle this and assign it a charge, the charge of this whole bubble would be +6. And now we have 3 SO4, 2 negatives. So let me write out all of those. So we have 3 SO4, 2 negatives. And if we were to assign a charge to that bubble there, it would be -6, right? Because each sulfate or SO4 2- group has a 2 negative charge. So the +6 and the -6 charges, they neutralize one another, and we are left with a neutrally charged compound. So let me just rewrite this over here. Aluminum sulfate is Al2SO4 3, and don't forget to put our brackets in because those are so important. Okay, that is a quick introduction to writing chemical formulas for ionic compounds. Hope that helped.